Hello.
Oh, hey, how's it going?
I'm doing well. Yourself?
Pretty good, pretty good.
Awesome. Well, welcome.
Uh,
So, yeah, welcome to the interview. So before we get started, when I went to go check on information about you and what this interview was for, it just says you want to practice high-level design, and it says that it has no other information. So before we start, could you tell me a little bit about yourself, maybe what experience you have, what you're studying for, so I can better plan this accordingly to help you meet your goals?
yeah, yeah, of course. Thanks for, I guess, like doing that. So I've been a developer in the Bay Area for about 4 years. And I guess I'll just kind of tell you the companies. So for the first year and a half, I was a kind of big data engineer at Salesforce. And there, I did, kind of like Hadoop, Spark stuff, and some database tunings. And
Mm-hmm.
for the past 2.5 years, I've worked for this startup that worked in real estate, and that was a lot more vertically. My work was a lot more like vertically integrated. For the entirety of the time there, I worked on the pricing team, and the majority of the time there, I worked on the resale pricing team. And there, a couple of my projects were, I had projects that were more like technical and projects that were more product based. So a technical project I did was redesigning our like unit economics pipeline to be more accurate for the homes that we have in our inventory. And a more kind of product based work I did was remaking basically making the entire process by which we price homes for resale. So originally it was very, I guess I would say organically grown, and then so it got kind of inefficient. And then we decided to redo it with like, models and better tooling. Yeah, so that's some like history. And I guess in terms of like, what I'm like looking for, so I have an interview tomorrow with Stripe, and I'm interviewing for a back end, I guess like financial data API role. So yeah, I guess something with back end and maybe APIs is would be good for this.
Okay, and I saw you switch to Python right off the bat. Generally, with system design, it's a little bit less writing code so much as more high level design. Do you want to be more specific into the API writings and like the nitty gritty of it, or do you want something that's more high level system design, like what I would give someone when they're interviewing with me at Amazon?
Let's do high level system design. Yeah, I think I switched to Python just by habit, but text is probably better for this.
Yeah, text is better for this, but I just want to make sure because if you wanted like an in depth like design a specific type of thing that would be coded
Right.
out, I can do that too. But I just wanted to make sure that we're on the same page.
Yeah.
So,
No. Yeah. Let's do just high level. Thanks.
okay, can I give you a question that I like to ask people at Amazon? I know it's not Stripe, but I'm sure that there's similarities. And
Yeah. Sure.
I have a couple things. First of all, would you like to design something that's going to be very specific to design a thing, or would you want something that just covers system design in general that's more of a generic thing to design?
Um. I I think generic. I guess. Yeah. Like I don't know what the Stripe system design is going to be. I gotta look online. I couldn't find any like. Well. Um. Hmm.
Okay,
Let's
well,
see.
I'll go with system design that I would normally give at Amazon then.
Yeah.
Um,
That's fine. That should be fine.
okay. I'm sorry, I don't know what they're going to ask you at Stripe, but
Yeah,
so
yeah. Well, I just like was looking and like to see if I could find like example problems, and actually like did see a couple, but I mean those I can look up myself. Yeah, just give me just just give me something new.
okay, and if you've heard this before, tell me and I'll give you something else. What I don't want to have happen is you just regurgitate something you already know because that's not very helpful.
Yeah, yeah, for sure.
Okay, so Amazon, when you're browsing the website Amazon.com and you look at products, you see that
Mhm.
products are ranked within categories. So if you're looking at
Okay.
like phones, you could type in like iPhone 6, and iPhone 6 has some sort of rank within cell phones and then some other rank within electronics, and it might be
Yeah.
in a few categories. It has different ranks within each category. Um,
Right.
I would like you to design the sales rank by category feature.
Find the sales rank by category feature.
Yeah.
Cool. Okay. So I guess my first question is like, what's the scope of this? By which I mean, there's obviously like a front end component where you have to like, I guess like look at it, and then there's like a back end component with like, ranking mechanisms.
So let's assume that you don't care about the front end. Some other front end UI person is going to deal with all of that. Your service just keeps track of where products are ranked within a specific category. So let's say that you are given, let's say Amazon hypothetically has maybe like 10 million products and 1,000 categories, but they can be a many to many relationship. So each product can be multiple categories, and each category can have multiple products.
Right, got it. So Amazon has 10 million products and 1,000 categories, roughly. Okay, cool. Let's see how.
Since you're only dealing with the back end, I don't want you to think about any front end stuff. Just assume that when the page loads, it sends a request to your service to get the rank of products. So if someone's looking at a specific category, they should be able to get the products from the category. If someone's looking at a product, they should be able to get the category from the product. They should be able to find the ranks of that in any combination.
Got it.
And if someone buys something, you can assume that it recalculates its rank. And rank is a rolling average. It's not going to be something that is set in stone. So for example, let's say the reason rank is a rolling average would be because the iPhone 7 was really, really popular a few years ago, but now no one's buying it for their new phone. So things that way, if something sold really, really well one time, they're not going to be stuck at the top forever.
Right. That makes sense. Let's see. So you say when somebody like buys a new thing, we want to update this. So I guess like in terms of latency, we want this to be like as accurate as possible.
Well, I think that having everything instantly updated would not be feasible just because of the volume that Amazon does. Let's say that billion items are sold every month. I'm trying to make the numbers easy to work with. I don't want to give you any weird numbers like 10 million items, 1,000 categories, 1 billion transactions per month. But results don't have to be updated instantly, but everything should be updated a minimum of hourly. And you might update popular products or things that have a lot of volume more frequently than hourly if you want to do that.
Okay, everything should be updated hourly, at least.
Yes.
Cool, that makes sense. Yeah, since it's hourly, then batch processing is possible. Cool. Okay, so I think I understand the kind of categories, or I kind of have everything I need. So very roughly, Amazon has 10 million products and 1,000 categories, many-to-many relationship. We want 2 endpoints. One's you get product ID, let's say product name or product ID, and we turn a JSON, for example, of the top categories it's in. The other way is we send the category, and then we get return of top hits and hits. And we want this to be updated roughly hourly.
Mm-hmm.
Cool. And just make sure. So for these products, on our back end, I'm sure can I just assume there's some API I can get to get new products and their information. And so 2 questions, I guess. One, how do we find out about new products? And 2, how do I get the sales information?
Okay, so for the first one, let's assume that there is some other API whenever a new product is added, its categories are selected, and it will just be sent to you. You have some sort of API that just calls you and says, hey, this product is being added with these categories. So you can either add a product or update a product with that API. And sales are generated whenever there's a transaction that happens. It's sent to you through some sort of sales API, and it says there was a transaction with X product ID and X number of units sold.
So when there's a transaction that happens, it can send something to me.
Yeah, it sends something to you. And you can pick exactly what's going to be in that transaction data that gets sent to you, what you need. But it should cover everything that you need. So if you want, maybe you can make a list of the things that you would need within the transaction and to make sure that
Yeah, got it. That makes sense. Let's see. Okay, cool. And
The
just
very,
so I'm sure.
I was just gonna say the very final thing is you should assume that people purchase only about 1% of things that they view.
Yeah. Okay, cool.
Once again, trying to keep the numbers nice.
Yeah, thanks. And I guess the final thing is, sorry, what was I gonna ask? Yeah, so popularity is just literally how many they buy, right?
Yes.
They bought within the past, X days. Cool.
Yeah.
Okay, yeah, that makes sense. So let's start, thinking of it from the like final end user perspective, I guess. So ideally they want these two APIs. Let me just draw some things. So here, I guess is like our final. Well, I guess we can start with a load balancer. So it's like text. Sure, and say this is like the load balancing that hits from the front end, and then behind this we can put a server that will return the response in case anything needs to be done, in case you have to add more bounds. And then from the response itself, since we have, let's say, 10 million products and 1,000 categories, that's not too many. So we can probably, put a cache that returns our API request, and that should make things a lot faster. So we put a cache here, and we can probably use a, key value store like Redis since it's not too complicated. Redis cache. So I guess the question is how does this Redis cache get populated? And so in our very, very back end, there's this database, right? And this database stores all our, stores information about the products, which categories they are. There's also, I guess, transaction history and product info. And then from this, we can actually find out, what the most popular things are. So of course, given that, actually querying this database would kind of take a while. So we need, some sort of batch job.
Okay. What kind of database would you choose?
Yeah. So I guess let's see. So for something like the product information, I think you should definitely have a relational database. And the product information isn't very there's not a ton of rows there, so scaling won't be an issue. For the actual transaction history, let's see, that's a lot of rows, and so I'm not sure a relational database makes sense. That's so for that something like a row-based database might make sense. So all it depends on the let's see, it all depends on the access pattern, right? So in this instance, if we're using this database exclusively for this batch job, basically we only need to get the rows within the past whatever, I guess X days. And given that that is fully ordered, or pretty close to fully ordered by the I guess order you receive them, a kind of row-based time series database or a column-based time series database like Cassandra or Redshift might make sense. So I guess it might make sense to actually have two databases. One Redshift kind of time series database for the transactions, and then a second I guess relational database for the records. The kind of issue with that is then you can't really join them. And then so you might have to kind of need to do two things. One is a group by of your transaction history, get some numbers. And then secondly, you then query your relational database to actually create your ranking. But I think that's fine. So yeah, so let's say here, this one can be we call this the relational DB. And something I think Postgres is only fine for this product info. And then this is I don't know how to delete on this, so we'll call this the time series DB, and this has a transaction history. Right.
And I can't see what you're typing until you finalize the text.
Okay. Yeah. So let's see. Like, there might be ways to like only have one DB because having two is kind of like iffy. But like I think this is like a nice way to think about it. Is that you have like these two types of data. One's like time series based and one's more kind of like relational, and then it might make sense to have two databases.
All right. So you have two databases. You have that you've just described.
Yeah.
Let's say that is your one service that's being called by. I don't really see where your server is. You have a load balancer, response, kind of a Redis cache. Where does your service itself sit in here?
Oh, yeah, that's response.
Okay, so the response is your
server. Yeah, sorry.
Okay. I just want to make sure. Some people might say it's something else, so I have to ask.
Yeah, of course.
So then your response is going to go. How is your response connected to the Redis cache versus the batch job? So the response always queries the Redis cache, and then the batch job just updates the cache periodically?
Yeah.
Okay.
Actually, I guess kind of like, so caches can go down, so it definitely makes sense to also we can put this in probably relational DB. It should probably like the batch job should update the Redis cache, but then also let's store like the information too. I guess like rankings here. We should store rankings somewhere in some DB, just so if the cache goes down, we don't have to rerun the batch job. We can just like get from the database. Yeah.
Okay, so do you have a separate service then that's calculating the rankings, or is your server response also calculating the rankings from the batch job?
No, the batch job runs every, I guess, like 30 minutes or hourly to calculate the rankings, and that updates the Redis cache.
Okay, so the batch job updates the Redis cache and it gets the. Okay, that makes sense.
Yeah.
Okay.
Cool. So let's talk about, I guess, like how we actually like update the transaction history.
Yeah.
So to your point, I think you said there's like every time something happens, it sends something to me. So I think updating the database every time that gets hit is like kind of dicey, just because your database might be down, you might not need to update all the time. So one thing you can do is have a queue, and also because you don't need like new transactions immediately because your batch job only runs every like 30 minutes. So you can have a queue. I think Kinesis or Kafka is the popular one. But the basic premise is that every time there's a sale, you write to this, and then so let's see. Let's also just add like a. Sorry, I'm just thinking about like whether or not we want to have I guess like not just a queue, but basically something that says like, hey, your message has been received by the queue. I don't know if that like comes out of the box with Kafka or Kinesis, in the sense that like the thing that's nice about queue is you can like send it and kind of like forget it, but it would be nice if you like send it and the queue's down, the sender gets a response that's like, hey, this is down. Let's come back to that later, because it's not like it might not be necessary. Like come to if we need it's like wrapper for queue. Yeah, but that's cool. So we have a queue, and then separately we have like we'll call this like ETL batch, or just ETL batch job. And what this ETL batch job does is it'll take information from this queue and let's say update the transaction history. Yeah. And then there's this other part that's when we find a new product, there's some API that the product hit, we can just hit. For that one,
So
you know,
going back for a second, the ETL batch job is so you're queuing up all these transactions. Whenever a transaction happens, it gets thrown into the queue. This
yeah,
ETL, like it basically drains the whole queue and then updates the database as a batch job. Is that what you're saying?
yeah. So it just yeah, I guess exactly that. It does like a bulk write to the transaction history.
Okay, so that way you don't have to do individual writes. You're doing occasional writes that have a lot more data. Okay, that makes sense. That way you have less writes. Gotcha.
Yeah, cool. So the other part of this is like how do we find out new products? This is some new API that we can hit. Let's see. Given that we also might need like another, I guess, like time job to hit this API for new products so that we can update our relational DB. Sure. Here's like what is our new product scheduled job. And this does something similar, right? It hits the API, gets new products. I mean, depending on like exactly how the API works, we might have to like send it the stuff we already have. But this job, its job, I guess, is to make sure that the relational DB with the product info is up to date too. Cool. And I think this is most of it. There is some, like I said, I guess like specifics we can make about, for example, this queue. Like, do we want to like return an error if it's down? Do we want like a wrapper around it, like a server in front of it? Yeah, that kind of stuff.
What would happen then if your cache disappeared? Let's say that someone didn't know what they were doing and they broke your cache.
The Redis cache.
Yeah, they deleted your node. Yeah. What would happen?
So in this instance, so that's why the batch job also wrote the rankings to the relational database. Because if your cache goes down, then we don't want to have to run the batch job again. So we can just like repopulate the cache using the rankings database. And two, then obviously we need like some way to like return the information. So it would hit this database.
Okay, that makes sense.
Yeah.
This is pretty good for the high level design.
Yeah.
You mentioned as we were starting that you really want to spend some time talking about the backend stuff and APIs and things like that. Would you like to go from here to going back to the writing part and actually write out your API calls, make a class called like sales ranker or something and define your API method calls, and let's see what you write for your actual method calls?
Sure. Yeah, let's do that.
All right.
Cool. So I guess for this one, it's just the Python. Let's see. So just to be clear, we're discussing like what the API would be for like from the thing that's hitting the server, or like my batch jobs, or I guess all of it.
So make a couple classes. Make like a sales ranker class that would return like all the calls that you would need to get like a product's rank and the categories and things like that. And then maybe make another class called like a static class called maybe like update sales rank or something, and then talk about what the API calls would be to actually update the rankings.
Cool. Okay. I think about that. So the sales ranker, it needs two methods, right? The first one is, I guess, get ranking by product, and we can probably use something like product ID for this. And I would have this return a JSON, or I guess dict is the. And the other one's get ranking by, or get products by category. Let's get ranks, yeah, by category, sure. This is with a category ID, and we'll have this return list. I think it's fine. Right. Um, yeah, and then update sales ranker. So the thing about like sales ranker is that in my implementation, it just tries to reach my cache, and like if that fails, it reads straight from the DB. So update sales ranker would I guess like update the cache, I guess. So we can call this like batch job. Might be a bit
Sure.
more accurate. Yeah.
No, that's a good point because it is a batch job.
Yeah. Yeah. Cool. So I would likely just have like one method that has to do both. I guess like update. I guess like run. And what would this take? So let's see. So probably I would have so I guess like it like I wouldn't like I obviously I probably wouldn't pass like all this information like through the XK like class. I guess I would probably have something like the Redshift URI, and then we'll say like I guess like transaction URI, DB URI, and then it's like relational product info DB URI. I've had some optional parameters like time to look back, and that's default is like 180, I guess, days. Yeah, so yeah, and this should be like URI class. I think it's this. And then the other thing I would have is what was the other thing? Oh, yeah, I guess like number of items to rank. This is int, which is like 100 or whatever. Yeah, I think that's good. I guess another thing to like consider is like when you init this, you probably have to put in some sort of like resource partitioning. So I guess like num workers.
Mm-hmm.
And whatever. And the other thing is I guess like cadence. Start time. Right, that's like date time. And then time or and time between runs. And this is time delta. Yeah. So this is roughly I guess honestly like the URIs and stuff should probably go in here too. Honestly, probably all of this should just go into init. But yeah, you basically need to like set your config for this job. And I guess the other thing you need is I guess like Redis URI.
That makes sense.
Yeah.
So when you are calling, let's say that I'm looking at my sales ranker and I want to find the top 10 items that are in the category of cell phone. How would I do that?
Yeah.
The category ID is probably going to be huge, right? If it's got, let's say it could have over 1 million items in it. Do I really want to get the whole list?
Yeah. I guess like in this like assumption, I kind of like assume that in this like number of items to rank, like I put 100 and then so I just store 100. But you probably are right that okay, so there's like a couple ways of doing this, I guess. So one is to just store like everything in like just have a giant list in your cache, and then that way you can when you call like get products by category, you can like query the cache and then like just say like get the first like 100 or so. The weakness of that obviously is like if you're only gonna get 100, then and you have like 1 million items, then that's like no good. The other way to do it, I guess, is like in your update sales ranker batch job itself. determine just like how many of these you want to rank. And I guess in this instance, there's no law that says, like your ranking that you do has to be the same results that you put in your cache. Like, for example, maybe for like historical reasons, you want to like know the full rank. But to your point, maybe in your get products by category, when you return it, right, you don't like want to like hit everything. So I think the way I would probably do this is have this thing called like, numbers of items to, I guess, like rank in cache, and then like have the stored number be stored 100. And I think it makes sense to have this be like, I guess, the way you limit the number of results is just like what's in the cache, because like the other way where you like store everything and then just like return the hundreds first foremost, then you have to like return everything from the cache. I don't know if there's a way that you can just like only query the first like 100 results from the list or whether in the key value store. I guess one thing we could do if we think like this number of like returns we want to get is kind of like dynamic, is to store it in chunks, by which I mean, we can have separate keys. So let's do this. So like, Redis keys. This, key values. It's like a Redis class. So we could have like, a key be equal to like, I guess like product ID. And then like, I don't know, like num start, and then like rank end, right? So rank. Right. Because, for something like this, so for example, if you want like, and then we would store this in like chunks of like 100 or whatever. And so the basic idea behind this is this offers you like a lot more granularity. I don't know exactly how the Amazon kind of get products by category works, but to your point, if there's like a million, maybe there's just someone who's like really gung ho about like seeing all of them. Maybe if they like just keep pressing next, then like they can get them. So in this instance, if we do that, then yeah, by the category ID, you can also get like rank start. And here we go rank start, I guess. Or do we need that for product ID? I guess we don't need. Maybe like rank end, I guess, would be this. This is kind of roughly like how popular it should be before you stop getting it. So let me add to do myself. Do what's keys for product. This should be category ID. Right. So in this case, if you want category ID, we can do pagination, where you like do them in chunks of 100, and like if someone really wants to get like a lot of them, you would like just keep paginating. In this instance, right, you wouldn't be able to get like like a million at once, but you only return like the kind of key rank. But perhaps getting a million at once is not a necessary like use case you have to support.
Yeah, that's cool. I think a million at once might be kind of an edge case, especially when you're looking at items. You generally don't see more than one or maybe a couple hundred items on a page. So needing a million would be excessive and probably only used for data analytics.
Yeah. So yeah, I think that's a good flag though, that to get products by category, we should like have some sort of pagination. And the second thing is get ranking by product. So I think the kind of like equivalent for that is like if you get a ranking by product, like how popular it is, I guess, until you just like, I guess, like don't show it. I don't know exactly how Amazon does this, and I don't know if maybe like for like more popular products or more popular categories, you want like a higher I guess like absolute number of like rank, as maybe like being 1,000 phone is a lot more impressive than being like a 1,000 sprinkler. I don't know. But yeah, yeah. So, but for this one, this is slightly harder to paginate, I guess, because you would need like this would be like category key. because you would need like a like product key. You go to something similar, but you have like you need like basically like repeat information because you only hit it once, and then so like if you like want to rank into like 10,000, you would like have everything before. So I don't think. I mean, I don't know if there's much to be gained by having like a dynamic like rank in for products within categories. What do you think?
I think that you're right. There's not a ton to be gained with that. The biggest issue that I had originally was the block pulling a huge amount of data at once. So I'm glad that you addressed that.
Yeah.
But yeah, in terms of the other one, I don't think it does. What would happen if, say, someone wanted to add an item that already had some sort of ranking information? Do you think that would be something that you'd want to support? Like, let's say that you were selling an item through some sort of third-party store and you wanted to also sell it on Amazon. And I, as a vendor, said, well, look, I have all this transaction data from when I sold this item for the past year. Can you use that to preset my rank?
Right. So the way that would be supported now is you would put your information in your queue, and then your ETL batch job would then like write it to your transaction database. Like, so I'm assuming like your product info is the same, and we just have this like new data that we have to incorporate into the transaction history. So in that instance, your like ETL job from your queue would write it to your transaction history. And it is a time series database. So when you like write that in bulk, you would have to resort it. But since we write it in bulk, that should be okay.
All right. So then you would just rewrite it, and then you just recalculate it from the data that got brought in, and then it would just have a rank the next time you updated the cache.
Yeah. I'm definitely more for item potency than updating.
Yeah, I think that is a good level of importance to put over it. If you have juice, I think that's the better one. Okay, mm-hmm. So this is starting to look pretty good. Let's see. No, I'm trying to think of we have about 15 more minutes generally of this interview. So I'm trying to think of, now let's say you've got this service, it's working pretty well, but all of a sudden Amazon decides to start selling something. Amazon buys Alibaba, and now there's like 30 times the number of categories, and now things are selling 10 million products, or 100 million products, and now it's hugely huger. How would you scale
right.
this to be bigger? So now you no longer, let's just say it's big enough now so that you can't fit everything inside of a Redis cache.
Right.
How would you go about going through your design to remove the Redis cache, but still have some sort of caching for fast utilization, but now knowing it's too big to just store everything in a single cache?
Yeah. So it's too big for one Redis cache, right? Can we like distribute our Redis? Can we get like more caches? And then I guess like partition them based on I don't know, like product ID.
Sure. I suppose you could get multiple Redis caches and partition them based off of product ID. So like, what would you do? How would you do that? How would you partition them based off of product ID? How would you calculate the sharding?
Yeah. So this has two keys, as category key and product key. And then so the I guess like most obvious way is just like hash of like category key. So I guess let me like not make suggestions until I like kind of understand the situation better. So I guess like with sharding strategies, I guess like the things that you should always kind of keep in mind is I guess like one, like does it is it like effective in the sense that do you ever like, because sharding doesn't do anything if you have to like hit everything. So is your like, do you have some sort of like natural partition key to shard it by? Let me write this down. Like for sharding, the natural partition key. And the other thing to consider for sharding is let's see, what's the other thing to consider is whether or not your load is I guess like evenly distributed. Far as you don't want one to be like completely dead and then one to be hit all the time. So I think for the first condition, we're pretty good. Given that each time we hit it, we just need either one category ID, and I guess a rank start, or one product ID. It's like very natural to shard it, using, let's say, the hash of like the product ID and the category ID. And even if you go round robin from that, you probably like, it's unlikely you like ever like your function code will never need to hit more than one of these at once. So that's fine. The second part of sharding though is that whether or not your load's evenly distributed. And this condition gets a lot dicier because if you just once again take hash modulo 10, then there's absolutely no guarantee that that will have equal load. So I guess like one way around that, I guess, so I haven't worked too much with sharding, at least like in this situation, but I guess like one way around it is like you could try being a little bit smarter about your partitioning by, so either like up front, so like so you have to do this like I think up front. Well, I guess you don't have to do it up front. You might be able to do it dynamically. So I guess like the first time you do it, you have to be like kind of dumb. But I guess like the second time you do it, so what would be nice? What would be an ideal solution?
An ideal solution would be something that would break it up with individual product ID, and then dynamically place the product ID into the individual instances that were less full.
Yeah. So sorry. Just to be clear, like this is the question I was asking myself.
Sorry, I was like, I guess I can tell you.
no worries. But yeah, you're right. So what would be ideal is if there was some dynamic allocation where like the code just did it. So so what we're actually looking for is the number of like queries this gets hit, right? Like the actual number of products is relevant, and even the number of actual sold is mostly relevant, though that might be a good proxy. What we actually care about is how often this API gets hit with this category ID and product IDs. So I think the ideal solution would be if we could somehow have a I guess like updating numbers for how often this API gets hit with various product ID, category ID. Then we could use that triple quotes. Then we could use that count to I guess like I don't know if dynamics the word, but yeah, I guess like let's say snake order by put into Redis by product and category, and that obviously wouldn't be like 100% good, but it's probably pretty good. Yeah, so I guess the question is, how do we get this API with various like product category IDs? So I guess like, one way is, given we have this like transaction history of, like we could use a method similar to our transaction history. The only thing about this, like kind of to your point, you like like people look at stuff a lot more often than they buy it. And then so like that seems like a lot of work, um, just to like dynamically update this Redis cache. Um, yeah, so I don't know, that might be kind of like using like a hammer to kill a fly kind of thing. Um, is there another way we could like roughly know how to like allocate this without having loaded the count? Um, is this like yeah, is this like yeah, is this like number of like views of this? Is this something that like we could like know without having to like add this other thing? Like basically, like, do we really have like Splunk logs that can like we can get this from?
Sure, yeah, you could have if you wanted to have Splunk logs, you could have Splunk logs of every single time that it was viewed, but that would be creating a huge amount of additional storage and logs that I don't think is necessarily required. And also Splunk gets very expensive when you store lots of things.
Yeah, yeah. Let's see. Yeah, so that doesn't sound great. Um, is there like a rough relationship, I guess, between like how often is there a rough relationship between how often stuff is bought
Versus,
and how often versus how often it's looked at?
we talked about that earlier, like half hour ago, and I said it's about a 1 to 100 relationship.
And I guess like my main question though is this like is it 1 to 100 for every product, or is it like are some products like 1,000,000 to 1 and some like 1 to 1?
So it's not evenly distributed, but overall it's that ratio.
Yeah, because
Selling $1 million yacht on Amazon, clearly it's going to be looked at many, many times, and it's only going to be bought once. But if someone is selling, I don't know, printer paper, it's probably going to be bought more often than 1 in 100, because no one browses printer paper related. People browse, $1 million electronics.
yeah, that makes sense. So I guess like so we already have a table of how often stuff is bought, and then let's say like like looks to like buy ratio is relatively static for product. If that's true, then given we already know how often stuff is bought from our batch job, then we can take that and multiply by our looks to buy ratio to get a rough estimate of looks, right?
Yeah, I think that's a fair thing you can do.
Yeah. So, this will be, much less computationally intensive. And then using this, we could use this as like, I guess, a rough heuristic for how to divvy up our data among the Redis caches. And then, like obviously from there we can still we can we can like look at like load as time goes on and like see if there's anything wrong with this. But as like a like V0 way to like dynamically allocate it, I think this seems okay.
Okay, yeah, I think that seems not too bad.
Yeah.
Also, right now it looks like we're about to approach the 50-minute mark, and I like to save the last 10 minutes of these interviews, or I guess 5 to 10 minutes that we have left, for feedback, both for you and me. So
Awesome.
if we jumped into the kind of the feedback stage of this, where we talk about how you did and things you could improve on, things you did well, that kind of stuff.
Mm-hmm. Yeah, let's do that.
Okay, so The very first thing that I look for when I'm doing a system design and I ask to make sure you understand the question is clarifying questions. You asked a few clarifying questions, but there were some things that you didn't quite ask, and since you were a little bit stumped on, I told you about, like the ratio of reads to writes, things like that, and the size of the data.
Got it. Yeah.
I think it's really, really important when you're doing one of these interviews to just ask a lot of questions in the beginning, because in system design, if I'm not, you mentioned that you've done some design in the professional workplace. Well, if you are designing anything, you're going to have like a 5-hour conversation with product managers about every single aspect of a design. So it's really important to just ask lots of questions and make sure that there's no miscommunications or missed assumptions.
Right.
The next thing that is use cases. We talked about the use cases pretty much as a kind of how the service calculates it. The user views should be able to view categories or products. So that was pretty good. We also didn't quite talk about scope that much. I told you that I don't want to talk about the e-commerce or the front end side, but what I was trying to hint at, but it probably got missed, and this is my bad, is I wanted to start from a specific location when you're doing your high level design. So I like the scope to like start and end with concrete locations. When you were starting your high level design, you actually started off like as your kind of as your starting point with as a load balancer.
Mm-hmm.
And it kind of caught me off guard. I haven't seen anyone do that. Generally, what I recommend for starting point, because you don't know where that came from with the load balancer, and the load balancers are generally something that is just kind of thrown in as like a middle step to prevent overloading. So I think this is kind of a little thing, but it's something that I notice every single time is you have to start at a concrete spot. So you could start as like the client making a call to you, or start with the client, or start with the front end, or start with something that's like a specific concrete location, because a load balancer is inherently a middleman.
Okay.
The load balancer doesn't generate a new request. The load balancer is you create a request and you send it to the load balancer to go to where it needs to go. So start with the place where the request is actually being generated. I think that's really important.
Yeah, that's a good flag. So in this instance specifically, I guess I could just draw like the very start was like, okay, client, I guess it's like the front end and just like makes a request, and then the next thing like, okay, request goes to load balancer, which then goes to server, etc.
Mm-hmm.
Cool. Cool.
The other thing is draw arrows or lines connecting things.
Yeah.
As you were talking about it, I was able to follow it reasonably well, but without that, I mean, you just have 9 boxes or 8 boxes.
Yeah.
I can count. Without arrows connecting them and talking about their relationships or how they interact, looking at this without the direct context of talking to you makes it really difficult to follow your high level design. I understand that you've got the label and stuff, but I think it's important to have direction.
Yeah, for sure. That's a good flag.
The next thing that I would say that you didn't really do is calculate usage. You just kind of looked at how much the requests are, how many categories and items, and you're like, oh, that'll just fit in Redis. But we didn't actually calculate like the usage of like how big is the transaction that's being sent to your database, like or how much data is being sent to your service every month. For example, let's say the transaction is 40 bytes and you have 40 billion bytes, then that's 40 gigabytes transferred to your service every single month. But like how much are you going to store? That leads to sharding and lots of other things. And a lot of the design comes into how much information is actually coming through. I think it's really important to take that extra minute or two to talk about what the usage is going to be. And then that way you can also figure out bandwidth. A single instance of Redis may be really, really fast, but if you are having a whole ton of concurrent connections trying to read from it, it's not going to work.
Right. Yeah, no, that's a super good flag. Thanks.
Yeah. The other thing is, I thought it was interesting how you were storing all of your pre-processed rankings within your database. Since they're already pre-processed, it seemed weird to store them within that database and make lots of rows for them in like separate tables. Wouldn't it have been easier just to store them maybe in an object store? That way you could have all the
Um,
archives as well, and you just put it in S3 or something.
oh, yeah. I guess sorry, by object store, do you mean just like not a database like S3?
Yeah, just since you've got it already pre-processed and everything, you could just export it somewhere. That way, you'd have archives of this stuff if in case something got lost. You'd know it was more secure than keeping it inside of a NoSQL database where things get changed up. Um,
Yeah.
it,
I think
it's
the reason I
specifically seen the archives of it stored within the actual database with the raw data. It seemed a little bit odd.
Yeah, I think that's good for like older data. I guess the reason I put it in a database is because if the cache goes down, if you want like fairly quick retrieval, then it's helpful to like have I guess like a backup database. But yeah, that's definitely true that for like well, I guess it's also just like yeah, but like for stuff way in the past, you don't need it in this database. Even if you like want to like look at later, you can like do something else with it. But yeah, it's not totally necessary to store like your like history in a database, especially for like prod queries.
Hmm. Okay, cool. So I guess that's basically the major points of feedback that I wanted to give you. When it came
Yeah,
to writing side where you're writing your API calls, I mean, the API calls looked fine. It looked like you have some experience writing backend APIs from your actual work. I think it shows.
right.
If that's not true and you made it up all up on the spot, you had me fooled. So that's all you needed to do pass your interview as well.
Sweet. Cool. Yeah,
Uh,
the that was a really good point about the right. Well, I just like Redis is like 10 million, like we're fine. I should have like done some number crunching, like what's the QPS, how many queries, like how many like things of like Redis do we need? Yeah, thanks a lot for that. The second thing I want to like one thing I did want to ask about is so you said in the beginning like I should have asked some like kind of clarifying questions about how like reach the right and the size of data. Um, I guess like I was gonna do that. So I think if I remember correctly, like the interview kind of went like okay. So I just started like asking about scope, and then I guess like after kind of like, asking about scope, you kind of like offered like Amazon's like the scale to me. I guess like my rough order was gonna be like okay, like make sure I got the use case like and then get the scale. Um, so I was gonna ask eventually like do you think it's like helpful to just like immediately ask about scale just so they like know I like will ask about scale.
Well, I think it's good to ask about scale before you start diving into the high level design. Most
Right.
design interviews, they expect you to ask about scale and then do some sort of usage calculation before you go into the high level design. And you were really quick to jump into the drawing page. Um, I think that you could have taken a step back, talked about those things in a little bit more detail so that you would know them. That way you don't have to go back and ask questions two-thirds of the way through the system design, because when you reach the halfway point, it's kind of expected that you already have all the data that you need. So when you're going back through and asking questions about usage and stuff, it's like, well, maybe you should have asked that before you designed it, because
Right.
maybe
Right.
the user do something that you didn't expect, and then your design's broken.
Yeah, yeah, for sure, for sure. Okay, cool. Yeah, I'll definitely be more cognizant about asking about like scale and numbers and like considering that more. Yeah, sweet. Yeah, that was great.
Cool. I'm glad that you liked it. And then I know we're just about out of time, but generally when I finish these interviews off, I'm always trying to improve my interviewing skills and make sure that people have good experiences when they interview. Do you have
Sure.
any feedback for me that would help me become a better interviewer for system design?
Yeah. Not really. Like that was actually yeah really good. You like looked at my like background and so you could like specify this to me. You like didn't find anything, and then like once that happened, you kind of like I guess like asked me like what I'm looking for. And I did that. No. I honestly don't have any feedback.
Okay, cool. Well, I'm glad that you had a good experience and that you got value out of this. I had a good time. I enjoy asking these questions. I have a small list of system design questions that I ask people depending on what they're looking for.
Okay.
Almost
Yeah.
always.
Yeah. Let's
Cool.
hope I get this in an interview tomorrow.
If you get this exact question in the interview tomorrow, that would be sweet.
Yeah. I that would be very fortuitous.
All right. Well, I'm going to end the interview now. Thank you for taking the time, and best of luck tomorrow.
Yeah. Thank you. That was great. All right. Have a good one.